So this is going over the periodicity, atomic radius, and ionization energies FIP quiz. And most people did pretty well on the first three questions, which were all writing noble gas notations. And the expectation there is sort of that you'll be able to write those without counting electrons, that you just kind of can do it now because of what you know about the periodic table. So the first thing that you were given to write a noble gas notation for was manganese, Mn, element number 25. And if you use the periodic table trick, you go, oh, okay, well, it would be just like argon, because that's the noble gas in the row above it. And then plus, well, where did we start filling with potassium? 1, 2, 3, 4. So manganese is just like argon plus 4s1, 4s2. And after 4s, we fill 3d. We hop back a level, so we go 3d, 1, 2, 3, 4, 5. So 3d5. And those weird little crossover things notwithstanding that we looked at in the D block yesterday, honestly, if you have it like that, I'm fine with that. We're not going to worry about memorizing the exceptions. Okay, so that was manganese. And whoops, get rid of all the extraneous stuff on here. So the next one you had was chlorine. And again, using the periodic table trick, you can say, well, chlorine is going to be just like neon plus, well, we start with sodium. So 1, 2, 3. 3s, 1, 2. And then what do we fill after 3s? We fill 3p. So we start after 3s, we fill 3p. So then we're into 3p, 3p, 1, 2, 3, 4, oh, 3p5. And that also kind of, you can double check yourself conceptually. That jives with what you should know, that noble gases have a full S and P. They're an S2, P6, and it's one short of being like a noble gas. Okay, the last one that you had, let's tuck these over here. Last one you had was strontium, and it's, let's get rid of all this. Strontium is in group 2, so you know automatically it's going to end with what? Something S2. Something S2. So strontium is here. So we're going to say, oh, well, it's going to be just like krypton, because that's the noble gas in the period above it. Plus, well, here we're in 1, 2, 3, 4, 1, 2, 3, 4, 5, 5s2, and we're done. Okay? Those were the things that people did the best on. I think those were pretty easy. Did you all use the shortcut, or were people still counting electrons? Most of you are using the shortcut at this point. It makes it really fast. It makes it really fast. And you may still need to draw the subshell filling diagram. If you know, I get confused sometimes, like, let's see, 4s, then what? Oh, 3d. And if you can't remember that drop back 1 for d's and drop back 2 for f's, it's fine to have the subshell diagram. Okay, the next one, ionization energy generally increases. Circle all that apply. What a mean trick. Having it be a circle all that applied threw a lot of people off, I think. Let's get a periodic table in here. Okay, so ionization energy. We know that ionization energy increases as we go this way. So ionization energy, it takes more energy to remove an electron from an atom as we go across a period. We know that, let me shrink this a little bit so I can do this. I'll write it sort of sideways. IE decreases as we go down a group. So IE increases across a period, it decreases down a group, which means, as a corollary, that IE actually increases as we go up a group. So the correct answers were B and C. IE increases as we go across a period or as we go up a group. We don't usually talk about going up a group. We usually talk about going down groups and across periods, but it's just true that there's a sort of a reverse pattern there. Questions on that one? Okay. Which of the following atoms would you expect to have a smaller radius than bromine? So because we're doing prediction here, I always circle the atoms in question. So we're now looking at atomic radius, and we're looking at bromine as our point of comparison. So if we think about atomic radius does what as you go this way? It decreases. Atomic radius decreases that way. Whoops. And atomic radius increases as we go down a group. Okay? So when we're looking at bromine and we're comparing it, we can compare it to chlorine. Would chlorine have a larger or smaller radius? Smaller. So that one definitely applies. What about potassium? Would potassium have a larger or smaller radius? It'd be larger. Iodine would be larger, and arsenic would be larger. So the only thing on that list that would have a smaller radius than bromine would be chlorine. Okay. Which of the following could you expect, and we'll get rid of all this stuff, to have a larger radius than potassium? So potassium is our first point for comparison. So if we compare potassium to cesium, cesium will have a larger radius than potassium. Are there any others that would have a larger radius? Lithium, would that be larger or smaller? Smaller. What about krypton? Over here. Smaller. So the only one that qualifies is the cesium. It's the only one that would have a larger radius than potassium. Okay, 7. As you go from group 1 to group 18, atomic radius tends to decrease. And that's what we just said there. Number 8 is a little bit tougher because you have to know what happens when you form an anion. What happens when you form an anion? Does radius increase or decrease? Form an anion, you add an electron. You now have more electrons pulling out than protons pulling in. They get bigger. Anions are larger than neutral atoms. Okay? So a negative ion is going to actually be a little bit bigger. So the things that we have here to compare are fluorine, boron, chlorine, and a Cl1-. And we want to put them in order from largest to smallest. So first of all, let's look at this trend. Oh. I will finish recording this. I will post it. If you have questions, comments, or concerns, I really want to get to the explanation of numbers 12 and 13. So I'm going to do some extensive conversation on that on the video, sort of a reteach. Because I'm feeling like you're not quite there with that. Okay, this was the hardest question on the quiz. So, when we're comparing these 4 things, it's really helpful to look at them in pairs. So let's first look at the chloride ion, Cl1-, and a chlorine atom, neutral atom of chlorine. Which one has a larger atomic radius? Well, we know that when we form a negative ion, the radius increases. So we're going to see that. We're going to see the chlorine ion is larger than the neutral chlorine atom. Okay. If we look at chlorine and fluorine, neutral atoms of each, which one will have the larger atomic radius? We know that as we go down a group, radius tends to increase. So chlorine will have a larger radius than fluorine. Well, what about comparing now fluorine and bromine. Well, we know that the radius decreases as we move this direction on the periodic table. So bromine will have the larger radius. Let's put that all together to put them in order of largest to smallest radius. So the largest radius of all will be our chloride ion, chlorine 1 minus. I'll just kind of move that out of the way. The next one would be our neutral chloride atom. And since we know that bromine is larger than fluorine, we'll put bromine next and follow it with fluorine. So Cl 1 minus, Cl, F, or B, and then F. And what was brought to my attention was I didn't have that option on the quiz. So in the answer that I had marked as correct, these two were reversed. These things are mind-bending. So yeah, this is the correct answer. My apologies for the mistake on the quiz. When you're doing these, I literally will do individual comparisons and then line them up. It makes it much easier. Okay, so now we're being asked to look at the following pairs and determine which is listed with the larger atomic radius first. So again, we know that atomic radius decreases as we go this way and increases as we go this way. So we'll look first at neon and carbon. Neon is here, carbon is here. Neon would have the smaller atomic radius. That's not it. Calcium and potassium. Calcium would have the smaller atomic radius. That's not it. Bromine and fluorine. And we know that atomic radius increases as we go down the periodic table. Bromine would have a larger radius than fluorine. That's your answer. But let's check to make sure it's not a tricky one where there are two possibilities. We have strontium and barium. Strontium would have the smaller radius because it is further up the group, so that's not it either. So number 9, the answer would be C. Bromine would have the smaller atomic radius. Okay, next one. 1/2 the distance between the nucleus of identical bonded atoms, we said, is 1/2 of that distance is the atomic radius. Okay, so now you're asked to place the following in order of increasing ionization energy. So smallest, i.e., to largest, i.e. Okay, well, what do we know about ionization energy? We know that I.E. goes up as we go this way, and we know that I.E. goes down as we go this way, in complete opposition to atomic radius. They have an inverse relationship. Okay, so if we compare, we have rubidium, iodine, silver, and tin, all within one period, and then we have sodium, which is up the period from, or up a group from rubidium, group 1 but higher than rubidium. So we want the smallest ionization energy there is, and let's first look at the ones in the group that are together. So we know that rubidium will have the smallest ionization energy of any of these, followed by silver, followed by tin, followed by iodine. Well, now we need to figure out where sodium fits in. So will sodium have a higher ionization energy than rubidium and go there, or will it have a lower ionization energy than rubidium and go there? What we know about ionization energy is that it decreases as we go down a group. So rubidium would have a smaller ionization energy than sodium. So sodium is going to go in between rubidium and silver. There it is. Smallest IE to largest. Okay. The next two are the essay questions, the short answer questions. And the first one you're asked is, describe the relationship between atomic radius and ionization energy. What is the basis behind both trends? Okay, so the first part of that can be answered as simply as saying the relationship between atomic radius and IE is an inverse relationship. It's an inverse relationship. As one increases, the other decreases. Now, the more complicated part of the question is, what's the basis behind both trends? And to answer that, we really need to think about what ionization energy is and what determines the size of an atom, what determines its atomic radius. So we know that the nucleus has protons, which have a positive charge, and electrons are out in the electron cloud at some distance. And we know that there is a powerful attractive force between these two things, pulling them together. So what we know is that the greater the force that the nucleus is exerting on the outer electrons, the smaller the atomic radius will be. Well, it's also true that the greater the force the nucleus is exerting on those outer electrons, the harder it will be to pull them off. So that's pretty much it. You can discuss electron shielding, you can discuss the actual basis of trends, but really it comes down to the fact that the more tightly the nucleus is pulling the outer electrons, the smaller the radius, and the harder it is to remove those outer electrons. So the last question on this, and the second of the short answers, explain why atomic radius tends to increase as you go down a group. As you go down a group, you add energy levels. You're adding higher energy orbitals. So the electrons on the outermost level are shielded from the effect of the attraction of the nucleus, the attraction of the protons of the nucleus, by those additional orbitals. This is often called electron shielding. So some people said, well, you add electrons. But if we go across a period, we have added electrons, but yet the radius has decreased. When we go down a group, we not only add electrons, but we add orbitals. So to put that in clear, concise words, as you go down a group, energy levels or orbitals are added, shielding the valence electrons from the attractive force of the nucleus, and thereby increasing the radius of the atom. Okay, that's it. I would suggest looking this over, going back to the chapter and looking through the questions there, and you will have your test on Monday. Have a good weekend.